This video is for Unit 8 exam review, page number 3, problems 13, 14, 15, and 16. Starting off, question number 13, we see that we are given a rectangle. In terms of solving a rectangle, we know that opposite sides are congruent. Additionally, we have the angles that are in the corners. We have 4 right angles listed all there, which is great. So to start off with, since I know that there are 4 right angles, we know that all 4 of these are right angles, meaning this 5z is equal to 90 degrees. And we can solve, giving us that z is equal to 18. Additionally, since we know that all 4 angles are right angles, we can set up a relationship between this angle, angle ADC, and then that 5x plus 8 plus 61 is equal to 90 degrees. We can combine like terms and solve here, giving us that x is equal to 3. Lastly, we are going to use the idea of that this is a right angle and focus on the triangle that is generated, which I'll highlight in green. From our diagonal BD, side DC, and CB, we now have a relationship happening between this triangle. We know there's 180 degrees inside. Substituting in the value of x is equal to 3 will generate this angle. Added with y and added with 90 should be equal to 180 degrees, giving us 8x plus 5 plus y plus 90 equals 180, or 8 times 3, which we solve for x, plus 5 plus y plus 90 equals 180. We can combine like terms here and then solve, which gives us y plus 119 equals 180, or y is equal to 61 degrees. Okay, question 14. Once again, we are given that we have a rectangle. We know that opposite sides are congruent. Additionally, we know the diagonals are congruent, that all 4 of these individual pieces are congruent, bisect each other, so we can set up several relationships here. So to help us solve for x, since we know the diagonals bisect each other and that the diagonals are congruent, we know that 6x plus 7 should be equal to 9. Then we can go ahead and solve this two-step equation, giving us that x is equal to 2. Since we know opposite sides are congruent, we can set a relationship between 3y minus 9, set that equal to 30, and 21 minus 6z equal to 15. Once again, giving us two-step equations which we can solve. Add 9 divided by 13, subtract 21 divided by negative 6, giving us y is equal to 3 and z is equal to 1. Okay, question number 15, we're changing it up a little bit in that we have a kite in both of these, 15 and 16. Relationships we know about a kite. We know that adjacent sides are congruent. We also know, very importantly, that the diagonals are perpendicular to each other, so we have 4 right angles generated in the center. Additionally, our main diagonal bisects our cross diagonal, so that means that these 2 pieces are in fact going to be equal. So the most obvious that we can have deals with the angles, which is our last property, is that the diagonal, the main diagonal, not only bisects this cross diagonal, it also bisects the opposite angles here. So we now know that y is equal to 35 degrees. Okay, well, how does that actually help me out? To solve the rest of them, we're going to go ahead and use the idea that the diagonals are perpendicular to focus on this triangle that I'll highlight in green to help us find out. We have a right triangle with 90 degrees, x, and 61 degrees, which I've drawn over here. So since the diagonal is perpendicular, it generates this triangle, which means that we can use the triangle sum theorem to help us solve for x. X plus 61 plus 90 equals 180, or x is equal to 29 degrees. Okay, we are once again going to use the idea of a right. This time we're going to look at this right triangle, which I'm highlighting in blue, to help us figure out the length of z. I'll redraw that over here. Except the fact that the diagonals are perpendicular doesn't affect we have a 90-degree angle. That helped us here. We're using triangle sum. In this top triangle, we're given 2 other side lengths. So actually, we're given 3 side lengths, and we're trying to find one of them, which means we'll be using the Pythagorean theorem to help us find our side length of z. 37 is the hypotenuse, giving us 37 squared equals 12 squared plus z squared. I'll subtract whatever the value of 12 squared is over, and then take the square root of both sides to undo the z squared. So that gives me a value that z is equal to 35. This kite problem, again, we use the fact that the main diagonal bisects opposite angles, and then really this diagonals are right angles. That property didn't actually solve the problem for us. We then utilized our right triangle, other practices that we know regarding right triangles, triangle sum theorem, Pythagorean theorem, to help us find the missing angle and side respectively. Okay, question number 16. Once again, we're given a kite. So that means that we know that non-adjacent sides are congruent. We know that the main diagonal bisects the cross diagonal. And we know that opposite angles are bisected by the main diagonal. We're not given any angle measures here. All of these are side measures. So that means we're going to go ahead and we'll start off by solving for x. The main diagonal bisects the cross diagonal. Or more importantly, that 2x minus 16 is equal to x minus 4. We'll go ahead and solve this multi-step equation. We'll add the x over, x minus 16. So subtract the x over, gives x minus 16 equals negative 4, giving me that x is equal to 12. Now we're going to go ahead and use the fact that consecutive sides are congruent to help us solve for y and z, giving us that 8y minus 2 equals 22, and 2z minus 5 equals 13. We'll go ahead and solve these two-step equations, giving us y is equal to 3 and z is equal to 9. One final note on kites. We have, in all the other types of shapes, this is the one where we have to utilize triangle sum theorem and Pythagorean theorem, other properties of right triangles that we've used in the past the most. Triangle sum also shows up more often in rectangles and Pythagorean theorem as well, but these two shapes we definitely need to make sure we remember our previous properties of a right triangle. Okay.